Dear students, good morning to all. So, I am Dr. Sumati Ramakrishna Gowda. Assistant Professor, Department of Computer Science, KSOE. So, as per the syllabus, we will study history of computers. Okay. So, in history of computers, actually the seeds of modern computer were sown 3,500 years ago when a huge stone carved structure spread in a circular pattern over the huge ground was used to perform astronomical calculations by considering the position of sun rays. Okay. This stone carved structure is known as Neolithic computer, and the mode of calculation is known as Stone Age calculation. Okay, you can see this figure number 2, Stone Age. You can see big stones here, na? So it is here 3,500 years ago. They used to calculate when the sun rays used to fall on these curved structures of these stones. Okay, so this computer, it is called as a Neolithic computer. So this Neolithic computer is the oldest computer found till date. The concept of computer in the medieval time was limited to a machine by which some calculation or computing could be carried out. Okay, so you can see now this is what the Stone Age computer. Actually, in earlier days, you know how people used to count their cattle sheep by using stones. They didn't know how to count, so they used to put pebbles, small pebbles, and with that they used to count. Okay, so here, so this is one Stonehenge. So here next is abacus. So abacus may be termed as a sort of ancient. This is the abacus. Figure number 3 you can see, na? This is called as the abacus. These are all very old computers. Abacus may be termed as a sort of ancient computer. Abacus were generally used for numerical calculations, and it is still widely used by merchants in Asia and African continent. Abacus is very popular among children in many parts of the world as it helps them to learn basics of calculations. It comes in different forms, size, colors, and constructions. You can see in a small beads. You might have seen children's slate, which consists of different green, yellow, blue, these small beads. Actually, that is the abacus. So here they used to do calculations using these beads. Okay, so you have already seen the slate with the beads and all. So this is the oldest computer, abacus. Okay, so so it's now about two pioneers who laid the foundation of computer science, that is Blaise Pascal and Charles Babbage. Blaise Pascal, after that, in 1642, French mathematician Blaise Pascal invented a machine which he named numerical wheel calculator. You can see in a figure 5 Pascal and small wheels here. At that time, Blaise Pascal was just 18 years old. Later, numerical wheel calculator became popular as Pascaline because this computer was named after him only. So this is Pascaline. Few years later, in 1673, German mathematician Gottfried Leibniz invented a mechanical calculating machine that multiplies, divides, adds, and subtracts faster than Pascaline. See, this is the machine which is invented by Pascaline. You can see this small wheels are there. All this you can go and see in the museum. These are all available still. Mm. So after in 1673, Gottfried Leibniz improved this machine, which can multiply, add, divide, and subtract faster than this machine. Okay. So here, this figure 5 shows you the Pascaline machine invented by Blaise Pascal. Now, next is Charles Babbage. The real beginning of computers as we know them today started with the efforts of English mathematics professor Charles Babbage. In 1821, Babbage invented a machine known as a differential engine to perform mathematical calculations. In 1832, he got an idea to develop another machine that could perform not only mathematical tasks but also any type of calculations. Soon he began working on the new machine, and in 1856 he succeeded in developing it. The new machine was named Analytical Engine. See, in the earlier Pascaline or Gottfried Leibniz, they were all differential machines. He improved these features. Charles Babbage improved all this and he designed an analytical engine which could perform all the mathematical operations. Due to his contribution in the field of computers, Charles Babbage is also known as the father of computers. See, after this class, you should be able to know who is Charles Babbage. Charles Babbage is the father of computers. Why he is called as the father of computers? Because he improved. The earlier machines could only do mathematical operations, basic mathematical operations such as multiplying, division, multiplication, division, addition, and subtraction. Then Charles Babbage improved, which could do differential and analytical mathematics. Okay. So here, figure 6 shows the image of Charles Babbage, and figure 7 shows the differential engine invented by Charles Babbage. Here, he is the Charles Babbage, the figure 6. And here in figure 7, you can see how he has designed differential engine, difference engine. After learning about mechanical computers that do not use software, let's now learn about early electronic computers that actually laid the foundation of today's computer. Then they started inventing ENIAC and EDVAC, ENIAC and EDVAC. See, these two are the electronic computers. ENIAC means electronic numerical integrator and calculator. It is called as ENIAC. Was the first electronic computer. So, which is the first electronic computer? ENIAC. So, two American scientists, John Presper Eckert and John W. Macaulay, jointly developed ENIAC on February 1946. Impressed by their invention, the American government decided to use it. ENIAC performed all mathematical calculations at a very fast speed. It could do 5,000 additions or subtraction and 360 multiplications in just 1 second. ENIAC was a big in size as compared to today's computer. It was 80 feet long, weighed 30 tons, and consumed lot of electricity. It was very expensive and beyond the reach of any common man. ENIAC was used to calculate the trajectories of bombs and shells. However, it can also be reset to perform other calculations by changing the connections attached to it. It had short memory and its components need a manual reset of wiring for performing different calculations. See, the figure 8 shows the structure of the ENIAC. You can see now It is a very big computer. It required lot of just more than 80 feet long and 30 tons means imagine how big it is. No normal man can purchase it. So next is John von Neumann. He is a scientist who proposed a new concept for storing information in a large internal memory that overcomes the disadvantages of ENIAC. See here, the memory was very small. Then John von Neumann, he advanced the machine by designing a new large internal memory. So what he did is his concept is known as stored program concept. He designed a memory which can store large amount of data. Based on this concept, a new computer came into market and called Electronic Discrete Variable Automatic Computer, EDVAC, EDVAC. So this is the figure 9 shows you Electronic Discrete Variable Automatic Computer. So this structure is called as von Neumann architecture. So this structure is named after John von Neumann. Okay. After getting familiar with ENIAC and von Neumann architecture, now you know how earlier, now the main thing is this is the advanced one, EDVAC, means von Neumann's architecture. So based on this architecture, the advancement of computers started. Okay. So just they started improving on this. This is the main thing. Memory is separate memory is there. ALU means arithmetic logic unit. Accumulator means that it's a small memory here. Then the control unit. Okay. So instead of RAM here, they are using accumulator. Okay. So this is the von Neumann architecture. Based on this architecture, they started developing. Okay. So advancement of the computer started from here. Now, next is IBM personal computer. You have heard IBM. IBM, they are the international company, international business machine. In late 1970s, international business machine decided to provide computers to common people. Okay. Actually, the generation of computers, the fourth generation started from 1970 only. So IBM developed personal computer in 1981. A personal computer can be used anywhere and by anyone. It fits on your study table. You can see this figure 10. This is the IBM personal computer. You can see here, this is the hard disk, and this is just, it looks like the Dabana. This is the old computers. Okay. Nowadays, it is the most popular type of computer. This is which shows in figure 10. After learning about the first ever build personal computer, let's become familiar with 5 generations of modern computers. Now we have learned, students, history of computers, how it started from the Stone Age. Okay, Stone Age. Then they designed ENIAC and EDVAC. After ENIAC, and they are the electronic computers. After that, John von Neumann, he made more advancement in the machine. Because of the John von Neumann architecture, the generation of computers started. Okay, hope you all have understood history of computers. And now we will learn generations of computers. After the first mechanical computer, the design of computers evolved over a period of time. Each generation of computer is characterized by a major technological development that fundamentally changed the way computers operate, resulting in increasingly smaller, cheaper, and more powerful and more efficient and reliable devices. The generation of computers are, it started from first generation computers started from 1945 to 1958. So during this time, the first business computers was developed in the year 1951 by the US Census Bureau. This computer was called Universal Automatic Computer, UNIVAC. The technology was based on vacuum tubes. See, you can see here, this is the vacuum tubes. These vacuum tubes were these were very large in size. The computers that used vacuum tube circuits were called first generation computers. The vacuum tube circuits contained a filament that was heated to emit electrons. See, you can a small filament, just like a bulb, a filament is there, which emits lot of electrons, which generates lot of heat. You cannot sit 2 to 4 hours continuously in front of computers and work. That was the disadvantage during this time. Some of the important features of generations are they are very expensive and non-portable, huge in size. It was bulky in size and occupied a lot of space, almost one room space. Then memories were magnetic core memories. Low level languages were used. Low level languages means machine languages, zeros, in the form of zeros and ones. Here, for writing the program, it was very tough, because writing a program in low level language is very, very tough. So processor speed measured in milliseconds during that time. So here input output operations were performed using punch cards. Okay. So you may not have seen punch cards, but all input output operations were performed using punch cards. So main application areas were scientific computation, record keeping, payroll processing, etc. They were using for scientific computation, record keeping, payroll processing, etc. Some of the important computers of first generations are Z3, Mark I, ENIAC, EDVAC, UNIVAC, etc. So these are all the first generation computers. See, after that, second generation started from 1959 to 1964. So here, during this time, vacuum tubes, see here, this is the vacuum tube. These vacuum tubes were replaced by this is a transistor, okay. So here, because of the invention of these transistors, here Bell Labs of USA, they invented transistors and were used in place of vacuum tubes. Instead of using vacuum tubes were replaced by transistors. Transistors are electronic circuits that are small in size and do not require any heating for emitting electrons. Okay. The computers that used transistors were called as second generation computers. Some of the important features of these generations are, see, because you can see here in the diagram, these transistors are very small in size. So when they replaced vacuum tubes, drastically the size of the computer changed to a very small size. Okay, you can see and imagine. So these some of the features are they become smaller in size when compared to the previous generation, and it generated less heat. Okay, so internal storage capacity was increased and processor speed measured in microseconds. Earlier it was measured in milliseconds. Here milliseconds, and here it is microseconds. Okay, see the improvements. It was very expensive, bulky in the previous generation. See here, milliseconds. Okay, so this is all improved. Processor speed is improved in microseconds during second generation. See, magnetic core memories are here. Primary storage. See here, primary storage. Here, machines started to evolve as series rather than standalone processors. Magnetic tapes were used for secondary memory. High-level languages such as COBOL and Fortran were used. Here, in the previous generation, in the first generation, low-level languages were used. Here the advances, high-level languages such as COBOL and Fortran were used. You know the COBOL expansion is Common Business Oriented Language. Fortran expansion is Formula Translation. So these are the first high level languages. So it is more reliable and less prone to errors. Some of the important computers of this generations are IBM 700, IBM 1401, ICL 1901, etc. See, these are all the second generation computers. Now we will move to third generation of computers. Third generation started from 1965 to 1971. So here you can see this diagram. This is the integrated circuits. Here the invention of integrated circuits replaced transistors. Okay, see, integrated circuits replace their transistors. In this generation, integrated circuits are also called as IC chips. So an integrated circuit consists of thousands of transistors and other electronic components embedded on a silicon chip. The computers became faster and reliable. See here, these transistors, these small transistors, thousands of transistors were replaced by one chip. This is the IC chip, integrated circuit chip. It replaced so many thousands of transistors is replaced by one IC chip. Now you can imagine drastically it changed the size of the computers. Okay, so mini computers were introduced. This generation saw the emergence of the software industry. So introduction of visual display unit made input and output operations very simpler. So processor speed measured in nanoseconds. See the processor speed. Earlier it was micro, mini to micro, micro to nano. In third generation, speed were measured in nanoseconds. System software called as operating system that controls the overall activities of the computer became common. So computers of this generation were using multi-programming concept, which allowed many programs to execute simultaneously. Disks were used as backing store medium, mostly used in order processing, airline reservation systems, and real-time inventory control systems. Some of the important computers of these generations were IBM 360, 370, NCR 395, and Burroughs B6500, etc. Next, evolution of fourth generation computers. 1971, fourth generation started till present. Okay, see here, you can see this. So the fourth generation emerged when the advent of large scale and very large scale integration circuits. That is large scale integration, LSI and VLSI. Further means microprocessor. We call this large scale, and VLSI means they are microprocessor. See, this is the microprocessor. You can see just one single board which contains all the transistors were replaced by all the many IC chips were replaced by this microprocessor. Okay, this is large scale and very large scale, which reduce the size of the computer. So here the size of the computer with the increase in performance, it increased drastically the performance. So which are that development of microprocessor based technology, what you called as a microprocessor. This is Intel and all you are seeing now, processor, motherboard and all. So development of microprocessor based technology, use of semiconductor chips for memory. Microcomputers and personal computers were affordable, were available to the common man. You know, the size became very small. The desktop computers you are using, laptop computers, they're all fourth generation computers. They are affordable. Anybody can buy, a common man can buy and work 24 hours together. So microcomputers and personal computers were affordable. Now it is affordable. Anybody can buy. Okay. So graphic terminals began to appear. A new set of software such as DBMS, database management system. spreadsheet were introduced. Spreadsheets is nothing but your Excel. Use of data communication and computer network became common. These generation computers were used in applications such as corporate modeling, decision support systems, electronic fund transfer, small business applications, etc. Some of the important computer generations were IBM PS2, Apple II, etc. So all today's computers, they are all fourth generation computers. Okay, now we are using AMD processor, Intel processor. So depending on the configuration, your computer has been charged. Okay. So fifth generation computers, they are still designing it. That is present and future. So this is robot. So recent research has focused on developing means, see all these 1 to 4 generation computers, you have to think and design. Here in future, if fifth generation computers means how they're designing is, these computers will think and they will take the decision. Here we used to think and we used to take the decision, right, in all these four generations. So here they are still designing it on developing thinking computers, means they should see, they should think and give the output. Earlier, if you give wrong input to the computer, it used to give wrong output. Okay, so here even if you give some wrong, it should be able to say that it is wrong, like that. Okay, so whatever you were feeding to the computer 1 to 4 generations, if you give wrong information, you will get wrong output. Means garbage in, garbage out. Here it is more advanced. So here these computers, they are still designing it by using artificial intelligence. So these computers are called the fifth generation computers and are developed in the laboratories of USA and Japan. So this will have ULSI. ULSI means ultra large scale integration technology with sophisticated operating system interface capability. These computers will have KIPS. KIPS means knowledge information processing system. Means here KIPS means it will only think and process. Okay, so they are still designing it. Some of the important features of these generations are introduction of organic chips, large storage capacity, high speed computers such as supercomputers were introduced, parallel processing, artificial intelligence, expert systems, robotics. So using all this, they are still designing it. Okay. So fifth generation computers are used in artificial intelligence, robotics, large scale corporate modeling, oil explorations, weather system modeling, etc. Some of the important computers of these generations are Cray 2, Param, etc. Means they are all supercomputers. Now, when you watch news or TV, in the TV, when you watch a news, here at the end they'll show you weather forecasting. Okay, it will say likely to rain, heavy rains, heavy snowfalls. See how you are getting through the supercomputer. Supercomputer displays all this in well in advance, so you can avoid the what this you can avoid floods. See, they will show you na likely to heavy rains, means you can become safe by shifting it to the safer place. Okay, so all disasters can be managed well in advance. So because of this, you can also you can use these supercomputers in where you can use in defense. So instead of doing manual, you can use robots. So you can use artificial intelligence. You can now drones and all they are using. They are all advanced computers. Okay, so students, today we have learned history of computers, generation of computers. So just we'll have a summary. So how history of computers, how it started from Stone Age, then ENIAC, EDVAC. Okay, so here just one walkthrough. We'll have a walkthrough. Okay, though now we have learned history of computers, those who have joined late. Okay, so here it started like this big stones where it is carved in a circular manner. So when the rays falls on these stones, they used to calculate. Okay, So this is your first computer, Stonehenge, then abacus, just like slate beads, which consists of colorful beads. So this is the abacus. Then Blaise Pascal. This is the Pascaline machine designed by Blaise Pascal. You can see the scientist. Then Charles Babbage. Charles Babbage is also called as the father of computers. This is the machine he designed, difference engine, ENIAC and EDVAC. So they are the first electronic computers. You can see ENIAC, such a big one, which occupied more than 80 feet. So then John von Neumann designed the architecture where it has a separate memory control unit, ALU accumulator. Based on this, the advancement started. So the first generation computers, there this is the vacuum tubes. It started from 1945 to 1958, which uh, which were which used vacuum tubes. Then transistors. Vacuum tubes were replaced by transistors, which started from 1959 to 1964. Then third generation started from 1965 to 1971. Third generation started invention of integrated circuits. These are the IC chips. Then IC chips in the fourth generation, 1971 till present. See, these IC chips were replaced by this. This is nothing but your microprocessor. Okay, then is fifth generation. This is robots, artificial intelligence. They are still designing it so that computer will think and decide which is correct or not. So they are using knowledge information processing system by using parallel processing, artificial intelligence. Okay, so all this you are seeing in the news and all, they are all supercomputers. Okay, so, students, we have studied generation of computers, then history of computers. You can refer the books, references, Vikas Gupta, then Alex Leon, Matthews. There are so many books are there. It is available in our mm, library also you can refer. Students, I also want to tell you, see, you when you go to youtube.com, you can also see my video lectures there. You can give computer fundamentals by Dr. Sumati Ramakrishna Gowda. If you give that, it will display you the video. This video is developed by our own university, our esteemed university, Karnataka State Open University, Mysore. You can go through that, because in that I have explained in detail how computer works inside the CPU. That I cannot explain here. You please refer my video. Okay, so do you have any doubts regarding this? Generations we have finished. History we have finished. Now I will introduce you to the introduction of computer. See, what do you mean by a computer? So the definition of computer, hardware, software, characteristics of computer, all that I have covered in my video, but still I'll just give a brief introduction of a computer. Okay, computer means, see, why do we need computers? We need computers to make our life easier and simpler, right? See, our lifestyle today, it has gone a sea change. Our lifestyle have undergone a sea change with the advancement of technology, especially in the field of computers. Computers are an integral part of our lifestyle. See, without computers, we cannot do anything nowadays. Where do you find computers? Everywhere: offices, homes, school, colleges, hotels, shops. Where not? Tell me. Okay, so this advance in technology has made our lives easy and comfortable. Now you are using mobile phone. Mobile phone is nothing but your portable computer, handheld device. See, it is making your life very simpler. All the messages you are getting in your fingertips only. Right? So without the computer, we cannot see. Any human being cannot survive till you have an oxygen. Okay, if you don't have access oxygen, you will not survive, na? So like that only, without computers it has become like that, we cannot survive. So for everything we need computers. So for instance, we can execute a number of activities using computer based systems. We can write a draft on word processor and email and make it calculations using electronic spreadsheet, incorporate graphics, create a database for our friends with their phone numbers, addresses, email IDs, etc. So it is an arduous process to perform these activities using existing traditional methods. Okay. Computers can also simplify other tasks such as word processing, designing website development, database management, etc. Therefore, a computer should be referred to as a data processor. See, computer means what? The term computer is derived from the Latin word compute means to calculate. In simple words, computer is an electronic device which takes the input from the user in the form of data and instructions. Once the computer receives the data, it waits for the user interactions to process the data. On receiving the instructions from the user, the computer processes the data and generates some output and displays it to the user. You can provide any type of data such as text, numbers, audio, video, and image to the computer. When computer processes data, it becomes information. See, students, in my video, I have explained you with a diagram. See how you are giving the data. You are giving the data through the keyboard. From the keyboard, where it is going to the input storage area. So from the input storage area, data goes to the program storage area. In that program storage area, all the calculations, whatever you have given a small program, it will be processed there. And then if you want to do mathematical, it will go to arithmetic logic unit, which performs arithmetic instructions. Okay, all that kindly go through my video lecture. Okay, so here computer is made up of two major aspects, which are the hardware and software. See, without the hardware, you cannot call it as a computer. When you have hardware and when you don't have software, it cannot be called as a computer. So it is so these hardware and software, these two are the major aspects required, which makes the computer. Hardware means it is the physical components of a computer. For example, CPU, input devices, output devices means you can touch and feel. Software means it is a set of instructions called a program. For example, Basic, Pascal, C, C++, Java. Basic expansion is beginners all-purpose symbolic instruction code. Pascal is a program which is named after Blaise Pascal. Okay. C, C++, Java. Okay, they are all softwares. They are all written in high level languages. So they are called as software. So the software you cannot touch or feel. For example, see when you switch on the light, the light, if the light glows, means if there is a current, light glows. If there is no current, light won't glow. Na? This light is a hardware. The current is a software. You cannot touch that software feel, because if you touch the current, what will happen? See, it is like that. Okay. So what do you mean by data? Data versus information. Now you know computer is an electronic. What do you mean by computer? Computer is an electronic device which takes the input, which processes it, and gives the output. So whatever the now data versus information. What constitute data? See, data means it is raw facts or figures. Okay. So there are four types of data: alphabetic or alphabetic, numbers, then alphanumeric, special characters. Alphabetic means capital A to Z, small a to Z. Alphanumeric means combination of numbers and alphabets. Numeric means 0 to 9. Special characters means what? Plus symbol, less than symbol, greater than symbol, all symbols. Question mark symbol, asterisk symbol, ampersand, hash, at, etc. So they are all called as special characters. Hope you understand now. Okay. So they are all data. Data may not mean anything to the users. They are raw data. So it is called as raw facts or figures. When the data is processed, it gives the information. Information means it is a meaningful. See, when I enter SUMA, see this SUMA is alphabetic. It does not have any meaning. When it is processed, it gives Suma. Suma is what? It is a name or something. Okay, so that is the Suma is a combination of alphabets. So these alphabets are raw. Suma is information. Okay. So the processed data is information which is have meaning, which has got meaning. Data does not have any meaning. So we call it as raw facts or figures. Okay. Information is the product of data, is the product of data processing. Information is meaningful to users, unlike data. It is secondary in nature, whereas data is primary in nature. Right? So data processing cycle. See how it works inside the computer. I have explained in detail in my video. Kindly go through it. Okay. So what is involved in data processing? See how data processing record, then originate means you are creating a record. Then you're after creating the records, you are arranging it, sorting it, arrange alphabetical order A to Z like that. Then you can use that data for manipulations. Then to generate the report, then communicate, deliver data, store or retrieve data whenever you need it. Okay. Then is need for information. Why do you need information for decision taking? So decision making, types of decisions and management. There are two types, structured and unstructured. A computer performs the following task. Input means it sends the data and command to the computer is known as input. Processing, work done by the computer with the help of processing hardware and software to produce results is known as processing. Output means the result displayed by the computer is known as output. Storage means a place to save result inside or outside the computer is known as storage. See, you can see here. This is the data processing. Okay. Here data is there, then here this is the your printer, this is the software. Okay, this is data processing involves all this. Okay, a computer is not made up of just a single device. It can be considered a system consisting of software and hardware devices interacting with each other and generating output to the user. Okay, this figure shows a computer with hardware devices and software involving processing the data. See how, see you are you are entering the data through the keyboard, it going into the machine, processing it. After processing it, you are printing. This is the printer. See, all this is the whole process is called as data processing. Okay, got it? You can have a, please go through my video lectures. I have drawn the figure, how it works, all that in detail I have explained. Okay. Okay, students, now we'll move to features of a computer, means characteristics of a computers. Nowadays, there are many computers with additional features. However, there are some of the common features which exist in each computer, be it in advanced or basic computer. These computer features are, say, speed. Speed means it determines the speed of computer to process all computations in fractions of second. It actually processes large amount of information in seconds and presents the output. 100 milliseconds. Okay. So the speed is very, very fast. 100 micro instructions per second. Okay. So here speed, you can you're already using computers, you can just imagine how fast it gives you. Okay, next is storage and reliability. Storage means determines the storage capacity of the computer, that is how much amount of information can be stored in the computer easily. Large, very large storage, 500 GB like that. Okay, 10 GB, 20 GB, 30 GB. See, the storage is huge, very huge. Abundant amount of data can be stored and you can rely on it. Okay, see, the whole textbook you can store it. Many number of textbooks textbook data you can store, but in the human beings can't store so much of data. See, when you study the whole textbook, you can't tell line by line, whereas your computer tells everything. Okay, so you can see how it is. You can imagine how much data you can store. Abundant amount of colossal amount of data can be stored. So accuracy determines the accuracy of the computer in providing accurate results of the computation performed by it. It actually does not commit mistakes until the input data has some error. Suppose if you give wrong data, it computes wrong output, right? Garbage in, as I told you, garbage in, garbage out. It never makes any mistakes. If you provide wrong data, it gives you wrong output. Versatility means determines where computers can be used, such as in the field of teaching, training, entertainment, accounting, hospitality, etc. Versatility means one computer can be used for many purposes. See, I am using computer for teaching purpose. Some other will use for entertainment, or film industry may use for filming their project. Serial people will use for designing serial, like that. Accounting they'll use for calculating the payroll. Hospitality, hospitals, hotel management, training, railways, airways, everywhere. So it is called as versatile. Versatile means huge purpose, many purpose. Next is diligence. Diligence means what? Determines for how many hours computer can work without getting tired. It gives an acceptable output even after running for long time. Nowadays, power, speed, capacity, and connectivity are the areas of focus for most of the users of computers, whether it is desktop, laptop, or handheld such as mobile phones. Diligence means it never gets tired. See, I can take the classes continuously for 3 hours. After that I'll feel tired, right? So continuously I can't keep on teaching. I need break in between. Whereas computer 24 hours it will work for you. So it is called as diligence. Now hope you understand the meaning of diligence, right? Okay, students. Now you have studied the characteristics of a computer. Characteristics means speed, storage and reliability, accuracy, versatility, diligence. So hope you have understood all this. Now you know you have learned the definition of computers. Computers means what? Hardware means what? Software means what? Then the characteristics of computer. So students, you have understood the definition of a computer. Now you know. Now if I ask you the question, you should be able to answer computer means what. No, you should. Now you are comfortable. I hope you all have understood data means what, information means what. After my class, anybody asks you data means what, information means what, you should be able to answer. Okay, you need not buy at everything. I told you, data means raw facts or figures, all alphabets A B C D, like that. It does not have meaning. When you join all this, it gives you some meaning. For example, MYSORE. MYSORE is a data. When it is processed, it gives you Mysore. Mysore is an information, right? So like that. Information means processed data. You should be able to answer. Now you know hardware means what, software means what. Hardware means where you can touch and feel. For example, CPU, then keyboard, monitor, printer. They are all hardware parts of a computer. Then software means what? It is a software means it is an operating system or a program. It is a set of instructions written in a programming languages, like high level language, such as I told you, COBOL, Pascal, Fortran, or Java, C++, etc. They are all softwares. You cannot see or feel the software. Okay, hardware can be touched and felt. Okay, I told you, I gave you a live example. When you switch on the light glows. You cannot touch that software. No? What is that software? Current is the software. When there is no current, your light bulb will not glow. Okay, so a tube light or any light glows when there is a current. So this bulb or tube light, it is an hardware part. The current software part. Now you have learned the characteristics. Characteristics means what? Speed, accuracy, storage, reliability, versatility, diligence, huge storage. They are all what? Characteristics or features of a computer. Now you have learned features, all that. Dear students, hope you have understood history of computers, generation of computers, definition of a computer, then how the data is processed inside the computer, hardware means what, software means what, characteristics of a computer. All this you have learned. Hope you don't have any doubts. So now next is classification of computers. See, this classification of computers is based on their construction and working, based on applications, based on size, speed, and capability. Okay, so here classification based computers can be divided into different categories depending on the size, efficiency, memory, and number of users. Broadly, they can be classified according to the following criteria. See, it is based on the construction and working, based on applications, based on speed, capability, and capacity. See, basically, uh, it is based on their construction and working. Actually, in my video, I have explained with the diagram how the computers are classified. Kindly refer my video lectures. Just go to youtube.com. In that you search, you give Computer Fundamentals by Dr. Sumati Ramakrishna Gowda. It will give you the it will display my video. Okay, this classification also with the help of a diagram I have explained. So kindly go through that. So here, based on the operating principles, computers are classified as one of the following. See, there are two types, actually three types. It is classified into analog computers and digital computers. Today's computers are hybrid computers. Hybrid means a combination of analog and digital computers, right? So here, classification of computers are based on their construction and working. Analog computers. These computers are used to monitor continuously changing signals. They contain analog devices and handle information which is of physical nature. Analog computers derive all their data for some form of measurement. They represent fractional or irrational values exactly with no round off. The accuracy of data used is an analog computer is directly related to the precision of its measurements. They use continuous physical phenomena such as electrical, mechanical, or hydraulic quantities to model the problem being solved. Analog computers find applications in chemical plants to process variation of temperature and pressure, or in petrol service stations stations pump that converts fuel flow measurements into quantity and price values. See, where do you use analog computers means they we use in hospitals. You might have seen in the form of signals. Analog signals means electrical signals. See, supposed to measure the heartbeat and all. They show the waveforms and all. See, they are nothing but your analog computers. They work with the help of electric signals, analog signals. When you go to petrol bunk, you will fill the petrol. It shows you the price and quantity, right? So it is the petrol flow is measurements of fuel flow is done in the form of analog. Okay, so analog computers, hope you understand analog computers means what. Okay, so next is digital computers. These computers can accept discrete data such as digits and other symbols processed and give output in a human readable form. For instance, a binary digital computer uses two discrete states such as positive or negative, high or low, or on or off. So digital means it is either 0 or 1. 0 means off, 1 means on. So it is called as digital. Only in the form of digits. of zeros and ones, so we call it as digital. It is used to represent the binary digits 0 and 1. It processes data which is essentially in a binary state. Unlike the analog computer, which is limited to the accuracy of the measurements made, the digital computer the digital computer accurately represent data using as many positions and numbers necessary. Digital computers have high memory capacity and are used in applications such as preparation of bills, word processing application, as well as in specialized applications such as solving simultaneous equation, etc. See, whatever you do in computer is all digital. Whatever you type is all digital. Means computer doesn't understand alphabets and all numbers, alphabets. Everything gets converted into zeros and ones. So it is called as digital computers. So you will be typing lengthy of your document. All that document in the form of alphabets, numbers, they're all converted into zeros and ones. So we call it as digital computers. Hope you have understood. Okay. Now, hybrid computers. As I told you, hybrid means it is a combination of analog and digital. Hybrid computers means what? These computers, it uses the principle of analog and digital computers. So it is called as hybrid. You know the meaning. Hybrid means combination of two. Hybrid computer is a digital computer that accepts analog signals, converts them to digital, and processes them in digital form. Even if you use analog signals also, that analog signals, whatever it is, everything gets converted into digital form. Now students, you know what is digital? Whatever the data you feed gets converted into digital. Digital means nothing but zeros and ones. See, after my class, everybody should answer that. Digital means what? Whatever the data you feed to the computer gets converted into zeros and ones. So it is called as digital form. So this integration is obtained by digital to analog and analog to digital converter. A hybrid computer may use analog data and produce analog or digital data. During its operation, a hybrid computer accepts a continuously varying input, which is then converted into a set of discrete values for digital processing. In general, a hybrid computer capable of real-time solution is less expensive than any equivalent digital computer. Hybrid computers offer a cost-effective method for performing complex simulations. They are also used in hospitals to measure the heartbeat of the patient, in scientific applications, or in controlling industrial processes. Classification is based on applications. Computers are available in different shapes, sizes, and weights. Due to these different sizes, shapes, they perform different sorts of jobs from one another. A computer that is used in a home differs in size and shape from the computer being used in a hospital. Computers act as a server in large buildings being used in a hospital. Computer acts as a server in large buildings, while the computer also differs in size and shape, performing its job as a weather forecaster. Let us look at the classification of computers based on their application. Now you can use for general purpose computers and special purpose computers. See, for general purpose computer, the name on it is general purpose, means one computer can be used for many purpose. So it is called as general purpose computers. These computers are designed to meet the needs of many different applications. In these computers, the instructions needed to perform a particular task are not wired permanently into the internal memory. These new instructions can be loaded as and when required for processing. They can be used to prepare bill, manage inventories, print sales reports, etc. For example, general purpose computers, say for example, you can use your desktop computers for typing the letter, or you can use the computer for designing the payroll by using excel sheet, or you can design your own ppt. Means you are using that one computer for many purpose, so it is called as general purpose. So special purpose computers means these computers are dedicated to cater the requirements of a particular task or application. These do not possess unnecessary option and thus cost less. Computers are built into high-end digital camera, automobile, fuel, and ignition, etc. See, the name on it, special computers means they are used for specialized computers. For example, digital camera is a specialized computer. Then automobile fuel means petrol bank. Then ignition control. See, the best example is washing machines in your house. Washing machine is a specialized computer. It only washes your clothes. That computer you cannot use for typing or running the applications. Okay, so here this washing machine is a specialized computer. How means a program is written in a normal computer. It is washing machine program is developed in a program called Java software. So here, how your computer should work, how your machine should work, they will write a program in Java, so that program is transferred into the chip. That chip is embedded into the washing machine, so your washing machine works. So how when you switch on your washing machine, it starts red means start. So the program is written from start, then what to do after starting: water, then rinse, then soak the clothes, then wash, then rinse, finally stop. So these are the steps. So from the starting till the end, a program is written. In a normal computer, it is transferred into a chip. That chip is embedded in the computer. Okay, you can, when you open the washing machine, you can see a motherboard with so many components on it. That is nothing but your microprocessor. Okay, so a chip is embedded, so it is called as special purpose. So in your house, you also have an oven. Oven, what it does, it only cooks your food. It bakes your cake, it bakes your biscuits, cookies. So the temperature is fixed. So a program is written in the target, in the host machine. Host machine is nothing but your desktop, transferred into the target machine. Target machine is nothing but your, for example, oven, washing machine, etc. So they are called as specialized computers. In order to cook baking biryani or like that, you have to make more you have to set the temperature to very high. So if you want to bake a cake, then you can set the temperature to 180 degrees, like that. Okay, hope you understand. You are giving the input through the inputs. Okay, so it will process, and finally the green light glows means your food is ready, output is ready. You can take the output, means the baked one. That is the output. Okay, hope you understand the meaning of general purpose and special purpose. Okay, children. Okay, students. I think tomorrow I will continue. We will study classification based on speed and capability. Tomorrow we'll study supercomputers, mainframes, mini computers, then workstations, microcomputers, laptops, handheld devices. Okay, so these are all the classification of computers, right? So tomorrow I will continue. Then the functional units of a computer, all this, kindly go through my video. So tomorrow you will understand better. Please browse my video. Please listen to my video lectures. All that I've explained. So tomorrow I will explain the classification of computers, then the primary memory, RAM, ROM, PROM, EEPROM, EEPROM, they're all the primary memories. I will explain you RAM, ROM means what. All this is the functional unit of a computer. Whatever the input, this is the functional diagram of a computer. All this I've explained very in a very comprehensive. I have explained in a comprehensive manner. Kindly watch my video. See, this is input unit. It is connected to the central unit, then output unit. So input unit means all the whatever the input devices, through the keyboard you'll be entering the data. Central processing unit means CPU. CPU consists of control unit. arithmetic logic unit, memory unit, all this. You can see this square. So this is your CPU. You can see na CPU. It looks like dabba. That is not a dabba, right? It's a box which consists of motherboard, all that. So which is mounted inside. So here output unit is nothing but your printer, monitor. It is connected. All you are seeing everything in the monitor, right? So secondary memory unit. What is this secondary storage devices? All that tomorrow's class I will explain you. Input unit means what? Storage unit means what? CPU means what arithmetic logical unit does, control unit, arithmetic logic unit. All this tomorrow we will study, students. So RAM means what? ROM, different types of ROM you tomorrow I will teach you. So before that, please go through my video lectures. Go to youtube.com. There you give Dr. Sumati Ramakrishna Gowda for computer fundamentals. So there I have given you very detailed explanation. Kindly go through it, students. Okay. Hope you have understood. Thank you for listening. Any doubts you can just ask me. If you have any doubts, you can ask me. Any doubts, students? Hope you have understood. Tomorrow I'll continue. See, if I teach you continuously, you'll also lose interest, right? I think for today's it's enough. If you have any doubts, you can ask me, or you can also put it in chat box. Thank you, students. Any doubts? I'm not getting any questions. If anyone is having questions, they can ask me. Unmute your microphone and talk to me. So whatever I have taught you, hope you must have understood. Any doubts regarding history? Any doubts regarding generation of computers? Any doubts regarding the definition of a computer? So hardware, software, how computer works inside. All that I have explained you in today's class. If you don't have any doubts, I'll just log out. Thank you so much, students. Thank you for listening. We'll join tomorrow. Thank you. I'll log out.